Thank you for inviting me to such a great conference, and I would like to thank the organizers for giving me this opportunity. I wish I was there with you guys, and also I would to thank and acknowledge the previous speaker for doing such a brilliant job on introducing the One Health concept in such a beautiful perspective, which actually comes quite nicely with what I'm going to talk about today. So, my name is Anastasios Tsaousis. I'm an accounting professor at the University of Kent in South East England, and I'm actually a molecular parasitologist, but I'm interested quite a lot on the microbiome. And I will actually try to convince you on the importance not only of the microbiome, but actually the eukaryotic components of the microbiome in one's health, which is all we are talking about this couple of days. So I'll split my talk into 6 different segments. I'm going to introduce human microbiome, animal microbiome, the soil, One Health, and the connection with everything we're going to talk about, the role of microeukaryotes, and actually I'm going to present some examples of microbial eukaryotes under One Health concept, and I will present some results of our research as well. So we all know in this conference and online as well, what is One Health, we need to consider having healthy people, healthy animals, and healthy environment. And all these are important under the microbiome perspective as well. Everyone needs to be healthy. In order for everyone to be healthy, the microbiome needs to be healthy. And when people talk about microbiome, they always think about the gut, but it's not only that, it's all the microbes that should surrounding a specific environment. And when we talk about microbes, it's not only about the bacterial components, it's all the, we have the archaea, we have fungi, we have eukaryotes that all play a role to have a healthy ecosystem in all of the environments, either in the gut, either in the skin, or the soil, the face, and so on. All these are interconnected, and this is what we need to actually take into account, both in health and disease. And I will start with the human, and when we talk about the human microbiome, as I mentioned, is interconnected with all of the organs across the body. And what is currently known, this is actually, I took this slide from a website just to give you an idea that all the information there actually refers to the bacterial components. Whenever you check something about the microbiome, rarely you see information about other things than the bacteria. But let's go through this just quickly to see what's going on. So we have 25 phyla of bacteria that are present in the human microbiome, and I'm talking about across all the organs, 2,000 in general, 5,000 species. 80% of these we know what they are doing. We actually map them into species, and there are 316 million genes. And this to give you a perspective that we have more foreign genes in our microbiome than actually the genes of our genes as humans. And this is quite important because, as you can see, we're more foreign, we're more microbiome actually humans. So, and there are a lot of unknowns. We know that there are microbes we haven't identified so far. There are hidden taxa and they're functional unknowns. So 40% of the genes that are encoded in the microbiome of humans are without a match in the functional database. So this gives you a perspective. There's still a lot to investigate on the human microbiome. And moving to what is my interest and what is actually the majority of the microbiome in humans and animals as well is the gut. So I'm not going to go through all these numbers here, but I'm just going to give you a perspective that from the gut you have a lot of connections across the whole body. We have the gut-brain axis, we have endocrine axis, heart axis, lung axis, liver, pancreas, bone, muscle, skin, reproduction, the blood. So all these are interconnected, and any dysbiosis of the gut actually affects all of these functions as well, all across the body. So the gut, when we say that a gut feeling, it's the microbiome. The microbiome can actually do all of these. And what this provides, what this provides is actually a lot of information on a bios as well. We can get from the gut fatty acids, antioxidants, it can reduce inflammatory mediators, it can decrease pathogenic colonization, and so on. So you can see that the gut is the connection axis to all of the functions in our body. But we talk about the gut, but we also need to actually see how this is influenced. And that's where I bring all the time the One Health. One Health is not around the world. It's actually, it can be from a household and look like the One Health within a household, within a village, within a city, within a country, within a continent, and so on. And what we can actually see is that there are certain bacteria within the gut that can be transformed, can be transferred, either within a household, within a geographic region, or within a family as well. And this actually allows us to understand better of what's going on the microbiome and the wound health. How about animals? Animals are not that dissimilar from humans as well. Obviously, there are different factors that are affecting the gut microbiome of animals. For example, I'm giving here the presentation of actually of a cow, and depending on how the cow is raised, for example, from post-genetic to transgenesis to rumen inoculation, fibrous feed, whether they are feeding essential oils, how the water is clean, how the starter feed is clean, whether there's a milk replacement, milk feeding, dam interaction, gestation, all this can influence the gut microbiome of the cow. And I will come back to that, what we are doing in my lab as a research, because all these factors are interconnected, and sometimes missing actually here is pathogens that can influence this as well. And if this is influenced in the right way, you can get a healthier cow, a more productive cow as well. If there is a dysbiosis early on, even at the first day after birth, then you have an animal that is not so productive or so efficient and cannot adapt to the environment as well. And in addition to all this, we need to look at how these are affected to actually to have a good animal welfare. It's not about actually having animals that can produce for us, but animals that are happy. Happy animals also have a much healthier microbiome and vice versa, and this can influence a lot of things as well, from CNS function to HPX, immunity, neural pathways, and endocrine. So taking everything into account, even when you talk to farmers, for example, is that have a happy animal. Happy animal can actually have a lot of benefits, not only for the farmers, but for the people that are using these products as well. The other thing to bear in mind, and this is where I wanted to bring another perspective, is that it's what the animals are eating. And this depends on how healthy the plants are. Okay, there is a real connection between the plants, the microbiome of the plants, and this can be both the soil microbiome or the microbiome that are in the leaves, for example, and how this influence animals as well. All these microbes are transmitted to the animals, and having proper microbes with proper plants with diseases, for example, with a good diversity of microbes, can actually provide a much healthier diversity of microbes that go in the animals, and the animals will be healthier as well. So everything is connected. Last but not least, I wanted to actually talk about the soil. And the soil here, as you can see, is affecting not only how a plant can actually grow, but also it can produce a lot of substances that are beneficial for the environment as well. A healthy soil correlates to a healthy environment. If you have a stress in the soil, for example, and you have a lot of intelligence, and you have a lot of things going on, you have a worse environment as well. Soil that will allow us to produce healthy environment and healthy plant as well, which are connected to the amount which comes to the human. And with this, I wanted to actually mention that microorganic links soil, plant, animal, and human health and microbial communities connected to different ecosystems. Soils harbours the most diverse and complex microbiome on Earth, and that can act as a microbial reservoir. Bad soil is likely the largest contributor to plant endophytic microbiota, contribute more than 2/3 of the bacteria to diversity. Diets play a major role in shaping the gut microbiome composition of both humans and animals. Plant microbiota, including microorganisms originally derived from soil, can also make their way to human and animal gut microbiota, as you can see from the figure. Farmers or farm animals are regularly exposed to soil, and we also inhale soil particles, including soil microorganisms, through that. Geophagy is the deliberate consumption of soil or clay. Sheep and gorillas, for example, and bats and parrots are a few animals that carry out geophagy. Human geophagy is also not uncommon. We do eat soil, and basically you can see that all this is a nice way to actually show the connection of this. Soil microbiota can come direct, and this with the solid arrows that you can see here, or indirect influence to the soil with the dotted one, plant, animal, and human health. Soil microbial communities play a pivotal role in ecosystem services, can have direct and indirect influence in multiple processes. Just to give you a rough idea how everything again are interconnected, from carbon availability to temperature pollution, sorry, to pesticides, to aim at rising temperature, elevated CO2, drought-ness, heterogeneity, all these can actually provide, can have an effect on soil health. Okay, and we again bring all the connections that have been discussed so far. So, I like this actually figure because it actually summarizes everything on one health and microbiome. So we can talk about local, regional, or global. We have the environment, the animals, and humans, and all these are interconnected, and we want everything to be healthy. But we can see from economy, climate, biodiversity, geography, anthropology, sociology, evolution, and demography, all these have an effect on the health of the microbiome, and of course, of human and the environment. And I just want to summarize a few ones just fast. I know the previous speakers already talked about this, but this is actually quite important in relation to the microbiome or health and disease. 60% of pathogens that cause human disease originate from domestic animals or wildlife. 75% of emerging infectious human diseases have an animal origin. And 80% of pathogens that are of bioterrorists concern origin from animals as well. Why I'm mentioning all this? If we have healthy animals, obviously a healthy microbiome that can actually deal with all the pathogens, this can reduce significantly as well. Talking about food security, each night more than 800 million people go to bed to be hungry. More than 70% additional animal protein will be needed to feed the world by 2050. And meanwhile, more than 20% of global animal production losses are linked to animal diseases. And all these are linked to the microbiome. So if we have a healthy microbiome that allows better production of animal protein, for example, deal with diseases as well, this would be solved. How about the environment? Humans and their livestock are more likely to encounter wildlife when more than 5% of regional forests covered with loss. Some of these contacts may increase the likelihood of disease transmission. So we need the forest. We need to actually plant more trees to keep this healthy environment. Human actions have severely altered 75% of terrestrial environment and 66% of marine environment. We are destroying our own environment, which is affecting obviously all the rest. How about the economy? We should always include the economy as well. Animal diseases pose a direct threat to the income of rural communities that depend on livestock production. And more than 70% of the billion people who live on less than $2 per day depend on sustained farming and raising livestock to survive. So we need to actually be able to teach them properly what would be the benefit of actually having animals and environment that are healthy. So what are the roles of microbial eukaryotes? When I talk about microbial eukaryotes, I don't refer only to fungi, but I actually refer to organisms like ciliates that are here. They have two nuclei around the cilia here. I'm talking about amoebae, and I'm talking about flagellate organisms as well, among others. And this can be found in rhizosphere, in plants, can be found around the soil as well. And many of soil products are unicellular fibroblasts, feeding on bacteria, where some feed on fat and other products and animals, thereby they affect the soil biodiversity and chemical interaction community with other soil microorganisms. This microorganisms actually provide a more diverse microbial community. They can engineer the microbial community to become healthier. There are symbiotes, some live in symbiosis, including parasites, commensalists, and mutualists, with fungi, other protists, plants, and animals. This also affects soil biodiversity, but also plants and above ground animals as well. Some protists, oomycetes, for example, which you can see here. Which you can see here, this is oomycetes, can participate as saprotrophs in organic matter. Anti-segregation, and this will actually allow you to provide more and make it more healthy. And some solvents contain chlorophyll and can be both phototropic or isotropic, and basically these have key roles of nutrient cycle soils. So I'm going to give you some examples of actually eukaryotic microbes that are correlated with within one cell. An obvious example is Polaris. This is the brain in amoeba. Is found in thermophilic environment. You can go the brain and kill you 3 days. Animals are not affected, but actually having eradicated, which is not beneficial in the soil, can actually get a much healthier animals the connection. So Sporidium, I need to talk about parasites. Obviously, it's a parasite, it's Tsaousis that is resilient to chlorine, for example. It gets sporozoids that infect the epithelial cells of the gut, and you get diarrhea, especially in the common humans. The outbreaks are everywhere in the world, and there are huge outbreaks in UK right now. There is no drug to deal with potential infection, and cryptosporidium, especially cryptosporidium album, is one of the 5 pathogens that account for most of the 50% of diarrhea diseases in animals. And obviously, there is a really nice connection you can see from the environment, humans to animals, and the one perspective. So we actually look at the microbiome of animals affected with cryptosporidium. We went to 20 farms and we screened about on this, and you can see this is the microbiome with animals with diarrhea with cryptosporidium. Cryptosporidium infection without diarrhea is here, and this is the healthy. And what you can see is that in the healthy animals, there's a much clearer correlation on the gut microbiome as well, and more diversity. Also, we also infected animals to look at how the microbiome is changing. This is a healthy cow, and you can see a drop on the community here is when they start feeding from milk changing to solid food. You can see some microbes changing. This is the microbiome with an animal being infected with cryptosporidium, and you can see a much less diversity after 3 weeks than here. This is a much healthier profile, and you can see with Clostridium, which is an indicator of the healthy microbiome as well, is highly increased in here, trying to actually recover the animal. And this, if this is affected at 3 weeks old, this will be a shorter, less productive animal in the long term as well. So the microbiome has an effect in the productivity of the animal. And I took this from a review showing what it can influence the animal microbiome, and what I actually refer to is that they need to look at the pathogens, and they need to look at the limits as well. So we need to find a way to eradicate cytosporin to provide them one health, not only to the environment, to the animals, and the humans. I will spend a couple of minutes to talk about blastocystis. Blastocystis is a controversial organism. It's been suggested that more than 1 billion people are actually carrying blastocystis. It has been found in the gut of individuals with and without diseases, and we don't know whether it's pathogenic and opportunistic or there is something specific on this animal. And we typically get this from the environment or from the animals, but research that we've done, we actually show that the transmission of blastocystis is more likely to come to humans from the environment instead of the animals, actually changing how are considered the transmission dynamics of blastocystis. And we've done this in northern Thailand, in one health study, and we continue to look at how this is transmitted in schools, for example, which have animals there as well. And we also look at if the growth of the genetics of human transmission, and with no correlation, what we've seen is that there was a consistent blastocystis colonization in some of the children or acquisition, and most likely the acquisition was coming from the environment, from the drinking water. So this raises a question whether the drinking water could be a source of transmission of blastocystis, and we actually see that in most of the cases it was, and actually this was a correlation with the water that was chlorinated. And we, under the One Health concept, we raised the question whether actually the chlorination we do in the water is the right one to deal with blastocystis. So just to give you an idea that typically 0.2 to 1 ppm of chlorine is effective to eradicate pathogen, and levels up to 5 ppm are considered safe in drinking water. When we've done study in different subtypes, we actually see that we need 20 to 100 times more of chlorine to actually eradicate blastocystis from the drinking water. So it's there in surviving our tap water where we're drinking. And when we look at the microbiome of blastocystis in humans, we actually see that depending on if humans are positive or negative with blastocystis, there was no change in the microbial profile. And there was no change with positive with IBS, with disease, or engineering the microbiome to support maybe recovery or any disease. So I hope I convinced you that we need to understand the roles of all players in the microbiome, and microbial eukaryotes are important players in all this, and they can play roles in manipulating or engineering the microbiome. This could be for good or bad, and there's still a long road to go through to understand all this. And we need to move out from the anthropocentric idea of the microbiome and look at the holistic view, and the One Health concept is the right move to follow. Healthy people are linked to healthy animals and healthy environment. This is my selling point. And with that, I would like to thank everyone